if you think about it, what this actually means is if I were to reduce, for example, my production of rabbits by 1 unit, then to remain on that slope, right, I would have to sacrifice 2 units of bananas. So in other words, it is, by definition, if you think about it, the slope is reflecting of your opportunity cost, right? In this case, it is basically reducing the production of rabbits by 1 unit. What do I actually have to pay in terms of bananas, basically? So that's how it all sort of comes together. The second idea is that the intercepts of the PPC can be used to ascertain who has the absolute advantage. Of course, we're assuming that everyone is working on the same time frame. So, for example, if we have a guy named Leo, right, and he's also got 16 hours per day, and let's say he's got 4 kg of banana per hour and 4 kg rabbits per hour. So if we think about it, right, what can he actually produce? He can only produce maximum 4 units of rabbits and 4 units of bananas, right? So what that suggests is that his PPC would look like this. So this is Leo's PPC. So if you now see this diagrammatically, right, it's fairly apparent that the intercepts, from the intercepts you can basically see who's got the absolute advantage, right? So the fact that Alberto can produce 16 units instead of 4 units of banana means that he's got an absolute advantage in producing bananas. And the same can be said for rabbits, because Alberto can produce 8 units compared to Leo's 4 units, right? So from this, we can identify who's also got the absolute advantage. We can then say, well, okay, from the slope, we can also say who's got the comparative advantage. If we look at the opportunity cost, it's basically 1-on-2 for Alberto and 1-on-1 for Leo, because 4-on-4. So since the opportunity cost is lower for Alberto, we can then say, well, he's also got the comparative advantage in producing, well, what do you guys think? I'll leave that for you guys to think about it. So that's the absolute advantage part. So the next bit is to think about concavity and the PPC. So what does concavity mean? So most of you guys may recall, right, your concave function as looking like this. Okay, so we have rabbits and bananas. It looks something like this. Okay, so that's a concave function. But if you think about it carefully, what is it actually reflecting? Right? Watch what happens to the slope. It's increasing, isn't it? Right? So that is then, if you think about it, also reflecting the principle of increasing opportunity costs, and hence, this is reflected by the increasing slope, right? So again, it all comes back to the definitions that we have basically discussed, okay? So the PPC is actually very rich in information, and I really hope that you guys have taken the time to sort of really explore this, because it is one of the key concepts in economics, and it is one of the, it basically lays the foundations for why we actually do trade, okay? So the next thing that we'll then be talking about is an example, okay? So I've already kind of implicitly went through this example, but let's sort of just walk through this step by step so that you guys are pretty clear in terms of what needs to be done. Okay, so we had Alberto and Leo, so there's a two-person economy. It takes 1 hour for Alberto to collect 1 kilo of bananas. It takes him 2 hours to collect 1 kilo of bananas, and we have Leo who takes 4 hours to collect a kilo of bananas and 4 hours to collect a kilo of rabbit. And let's assume that there are 16 hours in a day. So how do we actually do all of this? Okay, so let's first try and sketch the PPC. So the PPC is always fairly easy to do. Okay, what I always suggest that you do is you always construct a table. Alberto, and you have Leo. Okay, so you have rabbits, and you have bananas. Okay, so if you think about Alberto, right, he will take, for example, 2 hours to collect a kilo of rabbit. Okay, he will take 2 hours, and Leo will take 4 hours. Okay, so Alberto will take 1 hour, and Leo will then take 4 hours. Okay, so that's basically what we do know. We can also do the same thing if we write it in terms of opportunity costs. Okay, so if we were to think about this in terms of opportunity cost, right? If we think about Alberto, so what is the opportunity cost of then producing a kilo of bananas? So 1 kg bananas. Okay, for him to collect a kilo of bananas, it takes him 1 hour. So he alternatively could have used that to collect rabbits, right? So how many rabbits could he have collected? Well, it takes him 2 hours to collect a kilo of rabbits. So that suggests that his opportunity cost is half a kilo of rabbits. How about for Leo? Well, if we look at a kilo of bananas, it takes him 4 hours, and that 4 hours could have been used to collect rabbits. So it is 1 kilo of rabbits. Obviously, if we're looking at from the rabbit's perspective, it's just simply the reciprocal, right? Because if Alberto had used an hour to try to collect a kilo of rabbits, he would have had to use 2 hours. And what that suggests is that the sacrifice, the opportunity cost, is basically 2 kilos of bananas. And you can basically do the same for Leo. So from that, right, we can then draw the PPC. And whilst we've already drawn it, let's just make it very, very clear. So rabbits, bananas. Okay. So if there are 16 hours, Alberto will have 16 units of bananas, 1, 6, and 8. You have a straight line here. And for Leo, you get 4 and 4. Okay, so this is Alberto's PPC, and this is Leo's PPC. Okay, so hopefully that should be clear. But as always, if something is unclear, then most certainly please let me know.